Hello students, welcome to physics class. Today we are going to start the new chapter, that is the fourth chapter, that is moving charges and magnetism. In first three chapters we talked about the charges and electric field and electric charges, and when the electric charges are moving, that produces the current. These all concepts we discussed in the first three chapters. Especially first two chapters is completely electrostatics. Third chapter is current electricity. In first two chapters charges are stationary, but in third chapter you studied when the charges are moving, it produces the current. But in this chapter it is related to magnetic field. It is related to the magnetic field. See, as we know all, in day-to-day life we know the magnets. We are using so many purposes. In almost all of you know about these magnets. In our childhood also we played with these magnets so many times. It is a common to everyone. See, these magnets, how these magnets are came into existence in our day-to-day life, that is a big story that we will discuss in detail about the story about the magnets and how there are different types, natural magnets and artificial magnets are there. They are all discussing, we are going to discuss in the fifth chapter. But basically this magnetism, we are not concentrate only on magnets, we will concentrate on the magnetism. What is the magnetism? Magnetism is the property. It is a magnetism means is a property. Magnet means object. Object which has a magnetic property, that is called magnetism. General idea. For your convenience or for your sake of understanding, I am telling that magnetism word indicates it is a property of the object. It is the property of the object. Means if any object, if it has a magnetic property, that property is called as magnetism generally. And moving charges, why it is moving charges? See, these moving charges are directly linked with this magnetism property. If any particle or any object, if you want to say magnet, there must be a moving charges. Means moving charges and magnetic property, these are very interlinked with each other. They are very much close to each other. See, in our market, usually you know that in your high school section also, sometimes in your schools, your teachers shown that magnets, there are different types of magnets. Bar magnet, this type of structure of magnets ಈ ತರ shape ನಾಗ ಇದಾವೆ, bar magnet ಅಂತ ಹೇಳ್ತಾರೆ. If the magnet is in this shape, is called bar magnet. Sometime one more type, that is a horseshoe type magnet. This type of magnets are also there, and different types of magnets we are using. See, these magnets are permanent magnets. We call it as permanent magnets. These magnets produces shows the magnetic property. As we know already, if I bring the two magnets with each other, sometimes it will attract, sometimes it will repels. Understand? If I bring the two magnets very close to each other, then sometimes they attract each other, sometimes they will repel. When they will attract, if I consider two magnets, remember here also one magnet, this is one magnet, this is one magnet. If I bring these two magnets, if they repel each other, repel means they move far away from each other. When you bring these two magnets near to each other, they start to move back. They will repel with each other because both are north sides are facing to each other. If north is facing, then repulsion. If north and south are facing, if it is south, if it is north, then there is attraction, then there is a attraction. Remember, if you two opposite poles, we call it as a, when I consider the magnet, there is a two faces. One is north face or south face. Actually, we call it as a north pole and south pole. We have given a name. How this is, how we call it as a plus positive charge and minus negative charge. While in case of studying the charges, we consider two types of charge. One is positive charge, one is negative charge. Similarly, in studying the magnetic field and magnetism, we consider the two parts. There is a one south pole, there is a north pole. If always the opposite poles, means north to south attraction, south to north attraction, north north repulsion, south south repulsion. Means if you take the two objects or two magnets, if both north are facing with each other, this magnet north is this side and this magnet north is this side, if when you bring the very near to each other, they get repulsion. And similarly, if the south side of the one magnet and north side of the other magnet bring near to each other, they will attract. It shows that opposite poles attract with each other and similar poles repel with each other. South south ittandre enagtade, repulsion agtade. North north get repulse, but south and north they get attracts. This is our day to day experience. It is. See, here north and it is south. Why they have given a name north and south only? Why not they have given not other names? Okay, you can give any name, but already it's internationally everyone has accepted that is this part is north side, this part is south side. One is means one is north, one is south. Why they took this one, that we will discuss in a next chapter, 5th chapter. In detail you are going to discuss. But see, we will concentrate only this part, this type of magnet only maximum in our study. And see, if two magnets, if you say that they are attracting with each other, means when the north pole of the one magnet is facing towards the south pole of the other magnet, there must be some attraction force. This attraction force is indicated with some lines of force. Some lines of force. Some lines of force. As we studied in case of electric field, as we know now, electric field, if positive charge is here, the electric field starts and end at negative charge. Means these will, the positive and positive charges at positive and negative charges attract with each other, opposite charges attract with each other, same charges repel with each other. Similarly, how they are attract with each other? With the help of some attractive force. That attractive force is identified with some lines of force, that is called electric field lines. You know, positive charge avaglu negative charge na attract ಮಾಡ್ತದೆ. If these two are attractive, positive and negative attracting, there must be attractive force. ಅದರ ಮಧ್ಯೆ ಏನೋ ಅಟ್ರಾಕ್ಟಿವ್ ಫೋರ್ಸ್ ಇರಬೇಕು. ಆ ಅಟ್ರಾಕ್ಟಿವ್ ಫೋರ್ಸ್ ಕಣ್ಣಿಗೆ ಕಾಣಿಸ್ತಿರಂಗಿಲ್ಲ. ಅದಕ್ಕಾಗಿ ನಾವೇನು ಮಾಡ್ತೀವಿ, ಇಮ್ಯಾಜಿನರಿ ಒಂದು ಲೈನ್ ಡ್ರಾ ಮಾಡ್ತೀರಿ ನೀವು. ಈ ಥರ ಪಾಸಿಟಿವಿಂದ ಸ್ಟಾರ್ಟಾಗಿ ನೆಗೆಟಿವ್ಗೆ ಎಂಡ್ ಆಗುವಂಥ ಒಂದು ಲೈನ್ ಡ್ರಾ ಮಾಡ್ತೀರಿ. ಆ ಲೈನಿಗೆ ಏನಂತ ಹೇಳ್ತೀವಿ, ಆ ಲೈನಿಗೆ ಏನಂತ ಹೇಳ್ತೀರಿ, ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಅಂತ ಹೇಳ್ತೀರಿ. ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್, ಹೌದಾ? ಸಿಮಿಲರ್ಲಿ ಹಿಯರ್ ಆಲ್ಸೋ ಸೇಮ್. These north and south will attract, or south and north will attract, and north and north will repulse. If they attract or they repel, there must be a force. That force is called magnetic force. ಆ ಫೋರ್ಸ್ಗೆ ಏನಂತ ಹೇಳ್ತಾರೋ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೋರ್ಸ್. ಅದು ಎರಡು ಮ್ಯಾಗ್ನೆಟ್ಸ್ ಅಟ್ರಾಕ್ಟ್ ಆಗ್ತದೆ ಅಂದರೆ there must be some magnetic force. That force is called magnetic force. There must be some force. That force is called magnetic force. That force is identified or given by electromagnetic force lines. How electric force lines we studied, or electric field lines. Similarly, magnetic field lines or magnetic force lines. Those magnetic force field lines or electric magnetic force lines are noted like this. They start from N pole, always north pole, and it make the loop and it enter with the south, and again it will continues like this. There is no end for this one. They are loops, but in case of electric field they are not a loops. While explaining electric field lines, properties of electric field lines, I said that electric field lines never makes the loop, but magnetic field lines they make the loops. ಅವರು ಲೂಪಲ್ಲಿ ಫಾರ್ಮ್ ಆಗ್ತವೆ. ಲೂಪ್ ಅಂದರೆ ಹಿಂಗೆ ಸ್ಟಾರ್ಟ್ ಆಗಿ ಹಿಂಗೆ ಅಲ್ಲಿ ಯಾವ ಪಾಯಿಂಟಿಂದ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತಲ್ಲ ಅದೇ ಪಾಯಿಂಟಿಗೆ ವಾಪಸ್ ಬಂದ್ರೆ ಲೂಪ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಈ ಥರ ಸ್ಟ್ರಕ್ಚರ್ ಫಾರ್ಮ್ ಆಗಬೇಕು. ಇಲ್ಲೂ ಹಂಗೈತೆ, ಇಲ್ಲೂ ಕೂಡ ಅದೇ ಥರ ನೋಡ್ರಿ. ದೇ ಸ್ಟಾರ್ಟ್ ಫ್ರಮ್ ನಾರ್ತ್ ಪೋಲ್ ಆ್ಯಂಡ್ ದೇ ಫಾರ್ಮ್ ಒನ್ ಲೂಪ್ ಆ್ಯಂಡ್ ಅಗೇನ್ ಎಂಟರ್ ಟು ದ ಸೌತ್, ಅಗೇನ್ ಇಟ್ ಕಂಟಿನ್ಯೂಸ್ ಲೈಕ್ ದಿಸ್. One more. One. Like this. This is a structure of the diagram for the magnetic field lines for the magnet, bar magnet. Always the magnetic field lines start from north pole and continue with and enter into the south pole. ನಾರ್ತ್ನ ಹೊರಗೆ ಹೋಗ್ತದೆ, ಸೌತ್ ಒಳಗೆ ಎಂಟ್ರಿ ಆಗ್ತದೆ. ಇದು ಒಂದು ಕಂಪ್ಲೀಟ್ಲಿ ಲೂಪ್ ಆಗ್ತದೆ ಯಾವಾಗಲೂ ಕೂಡ. ದೆರ್ ಇಸ್ ನೋ ಗ್ಯಾಪ್ ಬಿಟ್ವೀನ್ ಹಿಯರ್ ಆಲ್ಸೋ. ಇಟ್ ವಿಲ್ ಕಂಟಿನ್ಯೂಸ್ ಲೈಕ್ ದಿಸ್. ದೇ ಸ್ಟಾರ್ಟ್ ಫ್ರಮ್ ನಾರ್ತ್ ಆ್ಯಂಡ್ ದೇ ಕಂಟಿನ್ಯೂ ವಿತ್ ಆರ್ ಎಂಟರ್ ವಿತ್ ದ ಸೌತ್ ಪೋಲ್ ಆ್ಯಂಡ್ ದೇ ಫಾರ್ಮ್ ಅ ಲೂಪ್. These magnetic field lines are responsible for attraction and repulsion. This much only. You should remember, ಮ್ಯಾಗ್ನೆಟ್ಸ್ಗಳು ಅಟ್ರ್ಯಾಕ್ಟ್ ಆಗ್ಬೋದು, ರಿಪಲ್ಷನ್ ಆಗ್ಬೋದು. ಯಾವಾಗ ಅಟ್ರ್ಯಾಕ್ಟ್ ಆಗ್ತಾವೆ ರೀ ಎರಡು ಮ್ಯಾಗ್ನೆಟ್ಗಳು? ನಾರ್ತ್ ಟು ಸೌತ್ ಅಟ್ರಾಕ್ಷನ್ ಮೀನ್ಸ್ ಅಪೋಸಿಟ್ ಪೋಲ್ಸ್ ವಿಲ್ ಅಟ್ರ್ಯಾಕ್ಟ್ ಆ್ಯಂಡ್ ಸೇಮ್ ಪೋಲ್ಸ್ ವಿಲ್ ರಿಪಲ್ಸ್. ಈ ಅಟ್ರಾಕ್ಷನ್ ಆಗಿರಲಿ ಅಥವಾ ರಿಪಲ್ಷನ್ ಆಗಿರಲಿ ಬಿಕಾಸ್ ಆಫ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್. ಹೌದು, ದಿಸ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಇಂಡಿಕೇಟ್ಸ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೋರ್ಸ್. That magnetic force is responsible for attraction and repulsion. Attraction and repulsion ಆಗಬೇಕಾಗಿತ್ತಂದ್ರೆ ನಮಗೆ ಈ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಬೇಕೇ ಬೇಕು. These are all imaginary lines. There is no any things, but they can exist. Even though it is imaginary, they can exist. These are imaginary lines, magnetic field lines. See, and one more thing we should remember, they start from north and they enter from the south. That's why they form the loop. How we studied is compared with the electric field lines. Similarly, this is also magnetic field lines also. ಯಾವ ಥರ ನಾವು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಕಲ್ತಿದ್ದೀವಲ್ಲ ಅದೇ ಥರ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸನ್ನು ಕಲಿತೀರಿ ನೀವು. ಅದ್ರ ಬಗ್ಗೆ ಡೀಟೇಲಾಗಿ ಕಲಿತೀರಿ. ಬಟ್ ಕ್ವಶನ್ ಬರೋದು, ಈ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗಕ್ಕೆ ರೀಸನ್ ಏನು? ವಾಟ್ ಈಸ್ ದ ರೆಸ್ಪಾನ್ಸಿಬಲ್ ಫಾರ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಪ್ರಾಪರ್ಟೀಸ್ ಆಫ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್? ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಐತೆ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದೀನಿ. ವಾಟ್ ಎವರ್ ಐ ಆಮ್ ಎಕ್ಸ್ಪ್ಲೇನಿಂಗ್ ರೈಟ್ ನೌ ಇಸ್ ಫೈನ್ ಸರ್, ಬಟ್ ವಾಟ್ ಈಸ್ ದ ರೀಸನ್ ಫಾರ್ ದಿಸ್ ಒನ್? ಯು ಕ್ಯಾನ್ ಆಸ್ಕ್ ದ ಕ್ವಶನ್. ಆರ್ ವಾಟ್ ಈಸ್ ದ ಸೋರ್ಸ್ ಫಾರ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್? ವೇರ್ ದೇ ಆರ್ ಎಕ್ಸಿಸ್ಟಿಂಗ್? The source of the magnetic field is moving charges. Remember, when the charges are moving, there is a magnetic field. If charge is stationary, only electric field. For example, if I consider one positive charge here, I kept this positive charge on here at this point. Just imagine this positive charge. If it is stationary, there is only electric field. ಈ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಯಾವಾಗಲೂ ಕೂಡ ಒಂದು ಸ್ಟೇಷ್ನರಿ ಫಾರ್ಮ್ನಾಗಿತ್ತಂದ್ರೆ ಒಂದು ಮೂವ್ ಆಗ್ತಿರಲಿಲ್ಲ, ಒಂದೇ ಕಡೆ ಇದು ಸ್ಟೇ ಆಗಿತ್ತಂದ್ರೆ ಇದು ಸುತ್ತಲೂ ಏನಿರ್ತದೆ? ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇರುತ್ತೆ. But same charge, if it is start to move with certain velocity, if it start to move with a certain velocity v, then it produces the magnetic field also along with electric field. Electric field will be remains when it is moving, but along with this electric field there must be a magnetic field also. This electric field and magnetic field both are perpendicular to each other. Both are perpendicular to each other. Remember once again, what is the source of the magnetic field? Magnetic field is produced by moving charges. If the charges are stationary, only electric field. When the charges start to move with a certain velocity, then along with electric field there is a magnetic field. This is the source of magnetic field. You should remember. The source of one line you write down the source of the magnetic. First magnetic field ಅಂದ್ರೆ ಏನು ಬರ್ಕೊಡ್ರಿ. Magnetic field. What is the magnetic field? Magnetic field is the region where magnetic effects can observe. Magnetic field ಅಂದರೆ ಏನ್ರಿ? ಇಟ್ಸ್ ಅ ರೀಜನ್ ವೇರ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಎಫೆಕ್ಟ್ಸ್ ಕ್ಯಾನ್ ಅಬ್ಸರ್ವ್. ಮ್ಯಾಗ್ನೆಟಿಕ್ ಎಫೆಕ್ಟ್ ಕಾಣಿಸ್ತಿರಬೇಕು ಅಂತ ಅದಕ್ಕೆ ನಮಗೆ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಆಗಬೇಕು ಅಂತ ಅದಕ್ಕೆ ಏನಂತ ಹೇಳ್ತೀವಿ ಮ್ಯಾಗ್ನೆಟಿಕ್, ಅದಕ್ಕೆ ಏನಂತ ಹೇಳ್ತೀವಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅಂತ ಹೇಳ್ತೀವಿ. ನೋಡಿರಿ ಒಂದು ಎಕ್ಸಾಂಪಲ್. ಇಫ್ ಐ ಕೆಪ್ಟ್ ದ ಒನ್ ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ ಹಿಯರ್, ಜಸ್ಟ್ ಇಮ್ಯಾಜಿನ್ ಹಿಯರ್ ನಾರ್ತ್ ಪೋಲ್, ಹಿಯರ್ ಸೌತ್ ಪೋಲ್, ಆ್ಯಸ್ ವಿ ಸೆಡ್ ಆಲ್ರೆಡಿ. ನಾವು ಏನು ಮಾಡ್ತೀನಿ, ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ ಅಂತ ತೊಗೊಳ್ತೀನಿ. ಇದಕ್ಕೆ ಎರಡು ಫೇಸ್ ಇರ್ತಾವೆ, ಒಂದು ನಾರ್ತ್ ಫೇಸ್ ಒಂದು ಸೌತ್ ಫೇಸ್, ಅಥವಾ ಅದನ್ನು ನಾರ್ತ್ ಪೋಲ್ ಆ್ಯಂಡ್ ಸೌತ್ ಪೋಲ್ ಅಂತ ಹೇಳ್ತೀರಿ. ಇನ್ನೊಂದು ಮ್ಯಾಗ್ನೆಟನ್ನು ನಾನು ಇಲ್ಲೆಲ್ಲ ದೂರದಾಗ ಇಡ್ತೀನಿ, ಅಟ್ರಾಕ್ಷನ್ ಆಗ್ತೈತೆ ರೀ? ಇಲ್ಲ. ರಿಮೆಂಬರ್, ಈವನ್ ಈ ಭಾಳ ದೂರದೊಳಗೆ ನಾನು ಹಿಂಗೊಂದು ಮ್ಯಾಗ್ನೆಟ್ ಇಟ್ಟು ಇನ್ನೊಂದು ಮ್ಯಾಗ್ನೆಟ್ ಇಟ್ಟಿವಿ ಅಂತ ಕೊಡ್ರಿ. ಇಲ್ಲಿ ಸೌತ್ ಐತಿ, ನಾರ್ತ್ ಐತಿ, ಅಟ್ರಾಕ್ಷನ್ ಆಗ್ತೈತಿ. ಈ ಕಡೆ ಸೌತ್, ಈ ಕಡೆ ನಾರ್ತ್ ಇದ್ರೆ ಆಗಬೇಕಾಗಿತ್ತಲ್ಲ. ನಾರ್ತ್ ಆ್ಯಂಡ್ ಸೌತ್ ಬೋತ್ ಆರ್ ಫೇಸಿಂಗ್ ಟು ಈಚ್ ಅದರ್, ಬಟ್ ದೇರ್ ಮಸ್ಟ್ ಬಿ ಅಟ್ರಾಕ್ಷನ್. ಅಥವಾ ಹಿಂಗೆ ಮಾಡಿಟ್ರೆ, ಈ ಕಡೆ ಒಂದು ನಾರ್ತ್ ಇಟ್ನಿ, ಈ ಕಡೆ ಸೌತ್ ಮಾಡಿದ್ರೆ ನಾರ್ತ್ ಆ್ಯಂಡ್ ನಾರ್ತ್ ಸೇಮ್ ಪೋಲ್ಸ್, ದೇ ಮಸ್ಟ್ ರಿಪಲ್? ನಾಟ್ ಪಾಸಿಬಲ್. ದೇ ವೋಂಟ್ ರಿಪಲ್ಸ್ ಬಿಕಾಸ್ ವಿ ಕೆಪ್ಟ್ ದಿಸ್ ಮ್ಯಾಗ್ನೆಟ್ ವೆರಿ ಫಾರ್ ಅವೇ ಫ್ರಮ್ ದಿಸ್ ಮ್ಯಾಗ್ನೆಟ್. ಈ ಮ್ಯಾಗ್ನೆಟ್ ಬಿಟ್ಟು ಭಾಳ ದೂರದೊಳಗೆ ಒಂದು ಯಾವುದೋ ಮ್ಯಾಗ್ನೆಟ್ ಇಟ್ಟರೆ ಅಟ್ರಾಕ್ಷನ್ ಆಗೋದಿಲ್ಲ, ರಿಪಲ್ಷನ್ ಆಗೋದಿಲ್ಲ, ಏನು ಸಂಬಂಧ ಬರೋದಿಲ್ಲ. ಬಟ್ ವೆನ್ ಯು ಬ್ರಿಂಗ್ ನಿಯರ್ ವಿತ್ ದಿಸ್ ಮ್ಯಾಗ್ನೆಟ್, ಇದರದ ಒಂದಿಷ್ಟು ಏರಿಯಾ ಇರ್ತವೆ. In this, around this magnet, certain region. In this region, if you bring the magnet, then there is a attraction. In this region. ಇದು ಬಿಟ್ಟು ಈ ಕಡೆ ಎಲ್ಲೂ ದೂರದೊಳಗೆ ಇಟ್ಟರೆ ಅದಕ್ಕೆ ಅಟ್ರಾಕ್ಷನ್ ಆಗೋದಿಲ್ಲ. This region is called as magnetic field. Means because the definition said like that, the magnetic field is the region where the magnetic effects can observe. ಮ್ಯಾಗ್ನೆಟಿಕ್ ಎಫೆಕ್ಟ್ ಅಂದರೆ ಏನು? ನಾರ್ತ್ ಪೋಲ್ ಸೌತ್ ಪೋಲ್ನ ಅಟ್ರಾಕ್ಟ್ ಮಾಡಬೇಕು, ಅಟ್ರಾಕ್ಟ್ ಮಾಡ್ತದೆ ಇಲ್ಲಿ ಈ ರೀಜನ್ ಒಳಗಿಟ್ಟರೆ, ಅದಕ್ಕೆ ಏನಂತ ಹೇಳ್ತೀವಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅಂತೇಳಿ. ಇದನ್ನು ಬಿಟ್ಟು ಹೊರಗಡೆ ಇಟ್ಟರೆ ದರ್ ಇಸ್ ನೋ ಅಟ್ರಾಕ್ಷನ್ ಬಿಟ್ವೀನ್ ದ ನಾರ್ತ್ ಆ್ಯಂಡ್ ಸೌತ್ ಪೋಲ್. ಅಂದರೆ ಪ್ರತಿಯೊಂದು ಮ್ಯಾಗ್ನೆಟಿಗೂ ತನ್ನದೇ ಅದರ ಸುತ್ತಲೂ ಒಂದಿಷ್ಟು ಏರಿಯಾ ಇರ್ತದೆ. ಪ್ರತಿಯೊಂದು ಮ್ಯಾಗ್ನೆಟಿಗೂ ಅರೌಂಡ್ ದಟ್ ಮ್ಯಾಗ್ನೆಟ್ ದೆರ್ ಇಸ್ ಸಮ್ ಸ್ಪೇಸ್ ಆರ್ ರೀಜನ್. ಇನ್ ದ್ಯಾಟ್ ರೀಜನ್ ಇಫ್ ಯು ಬ್ರಿಂಗ್ ದ ಒನ್ ಮೋರ್ ಮ್ಯಾಗ್ನೆಟ್, it experiences the force. It may be attractive or it may be repulsive, but it experiences the force. That force, that region or that space is called as magnetic field. Fine. Next we move on to the one more concept, that is magnetic field means source of the magnetic field. Source of magnetic field. What is the source responsible for to get the magnetic field? That is moving charges. Moving charges are source of magnetic field. Moving charges are the source of magnetic field. Moving charges are the source of magnetic field. ಏನು ನಾನು ಆಗಲೇ ಹೇಳಿದ್ದೀನಿ, if I consider one charge here, if positive charge or negative charge, any charge you take, but usually we take the positive charge. Okay, if I kept this charge here, it is stationary, then it has some electric field around this charge. Around this charge there is some electric field. When it start to move, this same charge, if it start to move with certain velocity, then it produces the magnetic field. Why it like that? That ಈಸ್ ನಾಟ್ ಅವನ್ ಅವರ್ ಸ್ಕೋಪ್ ಆಫ್ ದ ಸಿಲಬಸ್. ಯಾಕೆ ಹಂಗೆ ಆಗ್ತೈತೆ ರೀ ಚಾರ್ಜ್ ಮೂವ್ ಆದ್ರೆ ಏನಾಗ್ತದೆ ಅದಕ್ಕೆ ಅದನ್ನು ಆಮೇಲೆ ತಿಳಿಸೋಣ ತಿಳಿಸ್ತೀನಿ. ಬಟ್ ರೈಟ್ ನೌ ಯು ಜಸ್ಟ್ ರಿಮೆಂಬರ್, ಇಫ್ ದ ಚಾರ್ಜ್ ಇಸ್ ಸ್ಟಾರ್ಟ್ ಟು ಮೂವ್, it produces the magnetic field along with the electric field. Electric field will be there, but along with that electric field there is a magnetic field also came into existence. ಅಲ್ಲಿವರೆಗೂ ಇರ್ತಿರಲಿಲ್ಲ, ಬಟ್ ಯಾವಾಗ ಚಾರ್ಜ್ ಮೂವ್ ಆಗಿ ಸ್ಟಾರ್ಟ್ ಆಗ್ತದೆ ಆವಾಗ ಅದಕ್ಕೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಕ್ರಿಯೇಟ್ ಆಗ್ತದೆ. ದ್ಯಾಟ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಈಸ್ ಆಲ್ವೇಸ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಟು ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್. ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಮತ್ತು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಯಾವಾಗಲೂ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಡೈರೆಕ್ಷನಾಗಿ ಇರ್ತದೆ. ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಮೀನ್ಸ್ 90 ಡಿಗ್ರಿ ವಿತ್ ಈಚ್ ಅದರ್. This is the source of magnetic field. See, for example, next note, if I consider a conductor, very interesting here part. If I consider a conductor means wire, take the one wire. If positive charges are on this wire, consider positive charges. Usually electrons are free charges. Usually in every conductor electrons are the free charges, but right now you just imagine or consider positive charges are here. We can put the positive charges. Okay, on this I consider one wire or conductor, straight conductor. On this straight conductor there is a positive charges, they are moving. These positive charges are moving in this direction. Imagine ಮಾಡ್ರಿ ಇವೆಲ್ಲ ಮೂವ್ ಆಗ್ತಾವ. When these charges are moving, these positive charges are moving, we know that when the charges are moving they produces the current, must think, and when the charges are moving they produces the magnetic field. Charges move ಆಗ್ತಿದ್ರೆ magnetic field create ಆಗ್ತದೆ ಅಂತ ಹೇಳಿದ್ನ. Just a couple of minutes I said that when the moving charges are the source of the magnetic field, means if the charges are moving it produces the magnetic field. When the positive charges on this conductor, if they start to move, then it produces the magnetic field around this conductor. ಈ shape ಒಳಗೆ ಏನಾಗ್ತದೆ, in this way it produces the conductor. Remember, if I consider one conductor here, just imagine it possesses the lot of positive charges on this conductor. All are moving in upward direction. Just imagine all charges which are present on this conductor, all are moving in an upward direction. It means around this conductor there is a magnetic field. Around this conductor there is a magnetic field. Around this conductor, like this. If we bring, when all the charges are moving in the upward direction, similarly if all the charges are moving in downward direction, and that time also there is a magnetic field. Upward ಹೋಗಬೇಕಂತೇನಿಲ್ಲ, upward ಹೋಗಲಿ ಅಥವಾ downward direction ಹೋಗಲಿ, ಯಾವುದೇ ಡೈರೆಕ್ಷನ್ ಹೋಗ್ಬೋದು. Charges may move in any direction, but they produces the magnetic field. See, all the charges which are present in this conductor, if I consider all the charges are moving in a upward direction, it produces the magnetic field around this conductor. ಆ ಕಂಡಕ್ಟರ್ ಸುತ್ತ magnetic field create ಆಗಿಬಿಡುತ್ತೆ. Like this. Like this, completely magnetic field will produce. Yes. Then this magnetic field is a vector quantity. This magnetic field is a vector. What is the magnetic field? Magnetic field is the region where magnetic effect can experience, magnetic effect can observe. ಅಂದರೆ ಈ ಕಂಡಕ್ಟರ್ ಸುತ್ತಲ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಕ್ರಿಯೇಟ್ ಆಗ್ತದೆ ಅಂತ ಹೇಳಿದ್ನ. when I consider conductor, it has positive charges, all are moving in upward direction. Around this conductor there is a magnetic field. If there is a magnetic field around this conductor, if you bring the one more magnet near to this conductor, there is repulsion or attraction. Definitely, because the magnetic field definition tells us that it is a region where the magnetic effect can observe. ಇದು ಸುತ್ತ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಕ್ರಿಯೇಟ್ ಆಗೈತೆ ಅಂದ್ರೆ ಅರ್ಥ ಏನು ರೀ, ಇಲ್ಲಿ ಈ ಜಾಗದಾಗ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇರೋ ಜಾಗದಾಗ ಬೇರೆ ಮ್ಯಾಗ್ನೆಟ್ ಅಂತಂದಾಗ ಅಲ್ಲೇನಾಗಬೇಕು, ಫೋರ್ಸ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಆಗಬೇಕು. ಅಟ್ರಾಕ್ಟಿವ್ ಫೋರ್ಸ್ ಇರ್ಬೋದು, ರಿಪಲ್ಷನ್ ಫೋರ್ಸ್ ಇರ್ಬೋದು, ಎರಡರ ಒಂದು ಆಗಲಿಕ್ಕೆ ಬೇಕು. ಎಸ್, ದೇರ್ ಫೋರ್ ದೇರ್ ಮಸ್ಟ್ ಬಿ ಅ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್. ಈಗ ನಾನು ವಿಚಾರ ಮಾಡ್ತೀನಿ, then you can ask question whether magnetic field can measure ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಮೆಜರ್ಮೆಂಟ್ ಮಾಡ್ಬೋದಾ? ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅಂತೀರಲ್ಲ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇಂಟೆನ್ಸಿಟಿ ಅಂತ ಹೇಳಿದ್ವಿ. ಜನರಲ್ಲ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅಂತಲೇ ಹೇಳ್ತೀವಿ, ಬಟ್ ಆ್ಯಕ್ಚುಲಿ ವಾಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಮೆಜರ್ ಈಸ್ magnetic field intensity or magnetic field strength. What is the strength of this magnetic field? Sometimes if more charges are moving, high magnetic field will creates. If number of charges are moving less number, then magnetic field is less. ಜಾಸ್ತಿ ನಂಬರ್ ಆಫ್ ಚಾರ್ಜಸ್ ಮೂವ್ ಆಗ್ತಿದ್ರೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಜಾಸ್ತಿ ಐತೆ ಅಂತ ಹೇಳ್ತೀರಿ, ಕಡಿಮೆ ನಂಬರ್ ಆಫ್ ಚಾರ್ಜಸ್ ಫ್ಲೋ ಹಾಕಿದ್ರೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಕಡಿಮೆ ಐತೆ ಅಂತ ಹೇಳ್ತೀರಿ. ಅಂದ್ರೆ ಅರ್ಥ ಏನಿದ್ರೊಳಗೆ ವಾಟ್ ಇಟ್ ಮೀನ್ಸ್? ಇಟ್ ಮೀನ್ಸ್ ದ್ಯಾಟ್ it is a magnetic field strength. We can measure the magnetic field strength, not a magnetic field in particularly. But generally in examination or in generally while teaching or while talking, if I said that calculate the magnetic field, it is understood that you have to calculate the magnetic field strength only. ಅಂದ್ರೆ ಅರ್ಥ ಇಷ್ಟ ರೀ, ನಾ ಜನರಲ್ ಆಗಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಕಂಡು ಹಿಡೀರಿ ಅಂತ ಹೇಳಿದ್ರೆ ನೀವು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಸ್ಟ್ರೆಂಗ್ತನ್ನು ಕಂಡು ಹಿಡಿತೀರಿ ಅಂತ. ಬಟ್ ನಾವು ಮಾಡ್ತಿರೋದು ಏನಲ್ಲಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಸ್ಟ್ರೆಂಗ್ತನ್ನು ಹೊರತು, ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡ್ತಿರೋದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಸ್ಟ್ರೆಂಗ್ತನ್ನೇ ಹೊರತು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡನ್ನಲ್ಲ. ಒನ್ ಥಿಂಗ್ ಯು ಶುಡ್ ರಿಮೆಂಬರ್. ಈ ಕಂಡಕ್ಟರ್ ಯಾವ ಶೇಪ್ ಒಳಗಿರ್ಬೋದು, ಯಾವ ಬೇಕಾದ ಶೇಪ್ ಒಳಗಿರಲಿ ರೀ, ಬಟ್ ಚಾರ್ಜಸ್ ಮೂವ್ ಆಗ್ತಿತ್ತಾ ಅದು ಸುತ್ತಲ ಒಂದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಕ್ರಿಯೇಟ್ ಆಗ್ತೈತಿ, ಇಷ್ಟೇ ಫಸ್ಟ್ ಕೇಸ್. ಹೌದಾ? ಈ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಕ್ರಿಯೇಟ್ ಆಗ್ತೈತಿ. ಈಗ ಒಂದು ಕ್ವಶನ್ ಬರ್ತದೆ, ಆನ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ವೆಕ್ಟರ್ ಆರ್ ಸ್ಕೇಲಾರ್? ಎಸ್, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇಸ್ ಅ ವೆಕ್ಟರ್ ಕ್ವಾಂಟಿಟಿ. ವೆಕ್ಟರ್ ಕ್ವಾಂಟಿಟಿ ಅಂತ ಡೈರೆಕ್ಷನ್ ಇರಬೇಕಲ್ಲ ಅದಕ್ಕೆ. ಬರೀ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಸ್ಟ್ರೆಂತ್ ಅಷ್ಟೇ ಐತೆ, ಅದು ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಅಷ್ಟೇ ಇರಬೇಕಾ? ವೆಕ್ಟರ್ ಮೀನ್ಸ್ ಇಟ್ ಮಸ್ಟ್ ಪೊಸೆಸ್ ದ ಬೋತ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆ್ಯಸ್ ವೆಲ್ ಆಸ್ ಡೈರೆಕ್ಷನ್. ದೆನ್ ವಾಟ್ ಈಸ್ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ದಿಸ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್? ಈ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಡೈರೆಕ್ಷನ್ ಏನಂತ ಹೇಳೋದು? To understand this magnetic field direction, we use the thumb rule, right hand thumb rule. See, what is the right hand thumb rule? This, hold the your right hand in this way, thumbs up style. See, in this style when I hold, this thumb indicates the current direction and curving finger indicates the magnetic field. Thumb indicates the current and curved fingers indicates the magnetic field. If I consider the thumb like this thumb indicates ಕರೆಂಟ್ ಆರ್ ಮೂಮೆಂಟ್ ಆಫ್ ಚಾರ್ಜಸ್. ಕರೆಂಟ್ ಅಂದರೆ ಏನು ರೀ? ಮತ್ತೇನಲ್ಲ, ಚಾರ್ಜಿಂಗ್ ಮೂಮೆಂಟ್ಸ್ ಮೂವ್ ಹಾಕಿದ್ರೆ ಅದು ಕರೆಂಟ್ ಅಂತ ಹೇಳ್ತೀರಿ. ಕರೆಂಟ್ ಯಾವ ಡೈರೆಕ್ಷನ್ಯಾಗ ಮೂವ್ ಆಗ್ತೈತೆ ಅನ್ನೋದನ್ನು ಹೇಳೋದು ಯಾವುದು? ಥಂಬ್. ಈ ಚಾರ್ಜಸ್ ಎಲ್ಲ ಈ ಕಡೆ ಹೊಂಟಾವಲ್ಲ, ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಅಪೋರ್ಡ್ ಡೈರೆಕ್ಷನ್ ಹೋಗ್ತಿರ್ತಾವೆ. all positive charges are moving in a upward direction, means current is moving in this direction, and this curved finger direction, this is the magnetic field direction. Magnetic field ಹೆಂಗೆ ಹೋಗ್ತದೆ? ಹಿಂಗೆ ಹೋಗ್ತದೆ, ಹಿಂಗೆ ರೌಂಡ್ ಆಗ್ತದೆ, like this. If it make it reverse, ಹಿಂಗೆ ಮಾಡಿರಿ, means current is moving in a downward direction, then magnetic field is this opposite direction. When the current is upward direction, magnetic field is like this. When the current is downward direction, the magnetic field in here like this. Or if I consider one conductor, current is moving in the opposite upward direction, then hold like this. The current indicates, the thumb indicates the current direction. Current is moving like this. Then what is the magnetic field? Magnetic field direction is like this. The curved finger direction indicates the magnetic field. I hope it is understand for everyone. Very easy. The thumb rule. It is called thumb rule. If you change, if the current is moving in this direction, hold like this. The current indicates the up direction by thumb, and curved finger indicates the magnetic field. If the current is moving in this direction, hold like this. Current is this direction and magnetic field in like this magnetic field. If current is moving in this direction, magnetic field is like this. If current is upward, magnetic field like this. If current is downwards, magnetic field like this. This is the direction of the magnetic field. What we discussed till today, what is the source of magnetic field, what is the types, what is the magnetic field lines. Magnetic field lines means they always makes a loop. They start from north and they enter into the south. Always opposite poles will attract with each other, same poles repulse with each other. What is the magnetic field? What is the magnetic what is the source of the magnetic field? Source of the magnetic field is the moving charges and thumb rule. And magnetic field, we can't measure the magnetic field directly. Magnetic field strength we are going to measure in generally. Okay. What is the vector or scalar quantity? Magnetic field is a vector quantity, and the direction of the magnetic field is studied with the help of thumb rule. With this, I am going to close this class today, and remaining class I will continue in a next class. Thank you.